Let's continue with the tangent function. So another formula for tangent is tangent x is equal to sine x over cosine x. Why? Because when you draw your right triangle, okay, let's draw it here. So let's say this is our angle x, and we have this ABC right triangle. And let's say here is the length of A, here is the length of B, and here is the length of C. So we know that tangent x is equal to opposite side, okay, opposite side, which is here, is equal to C. Tangent x is equal to here is C opposite side over adjacent side, right? So here it's equal to A. So it's C over A. So how do we find sine x? Sine x is equal to opposite side over hypotenuse, right? So here opposite side is equal to C and hypotenuse is equal to B. And cosine x is equal to adjacent side over hypotenuse, which is here equal to A over B. So our hypotenuse is equal to B. So we said that tangent x is equal to sine x over cosine x. So let's divide these two together. So sine x over cos x would be equal to C over B. We put opposite B over A. So this will cancel out each other. And from here we will get C over A, which is, as you can see, equal to our tangent x value. Now let's see how this tangent function looks like on the graph. Let's say on the unit circle we draw our x angle as here, and we want to find our tangent function. Okay, to find the tangent we draw a parallel line to y-axis, as you can see here, and it should touch the circle on this point. Okay, when you make your so here all you have to do is you make longer your radius. So here we have our radius, right? So we make it longer till this line here, and this point, from this point to x axis here, this is your tangent x value. Why? Because since this line touches here on this point, right? So this is equal to 1 because our radius is equal to 1. So tangent is opposite side over adjacent side, right? So here our opposite side is this length and our adjacent side is equal to 1. That's why this length becomes your tangent line. So this is your tangent value. For example, let's say we want to find the tangent value of 150 degrees. Okay, so 150 degrees, it's somewhere here. Let's say this is 90 degrees. 150 would be somewhere here. Okay, so this is 150 degrees. So as you can see, there is no parallel line to y line, right? So here, what you should do, you should just draw like this line, okay, till here. Okay, so here from this point to x-axis, it will give you the tangent of 150 degrees. So here is the value of tangent 150 degrees. Okay, so as you can see, it is negative because this is equal to this value of y. When you do this, as you can see, it's -1, this is minus side, negative side. That's why the value of tangent 150 degrees is actually, it's negative. So let's say we want to find the value of tangent 0. Okay, so tangent 0, so it's here. So when your radius on 0 degrees, it is 0, since there is no vertical height, there is no vertical line here. That's why it's equal to 0. Okay, so when you want to find, for example, let's say tangent 90 degrees. So when your radius on 90 degrees here, this here is our 90 degree, right? So when it's here, as you can see, it's parallel to this line. So since they are parallel to each other, it means that these lines will never intersect. That's why there is no value of tangent, and that's why it is undefined. We called it as undefined. Okay, since they are parallel, they will never intersect. That's why this is undefined. So when we want to find, for example, the value of tangent 180 degrees, okay, so it's here, right? Our 180 degree is here. So when you reduce on this degree, there is no vertical height, right? Because it has to be vertical in order to find this value of tangent. So that's why it is equal to 0, as we found for tangent 0. So when we want to find the value of tangent 270 degrees, so here it's here, right? 270 degrees. It's also same as 90 degrees. Since these lines are parallel and they will never intersect, we say that it is undefined. So this is how you find the value of tangent on the unit circle. Let's continue with the cotangent function. So another formula for cotangent x is equal to cosine x over sine x. Why? So let's draw our right triangle here. So as we know, when I draw my right triangle here, as we know, cotangent x is equal to adjacent side over opposite side, right? Let's say this is a triangle of ABC, and this is the length of B, this is the length of A, and this is the length of C, and this is our angle X. Okay, so here what is cotangent X? It is adjacent side over opposite side. So adjacent side is equal to A over opposite side is equal to C, right? So this is our cotangent X. So how do we find our cosine x? It's equal to adjacent side over hypotenuse, right? Cosine x, which is equal to adjacent side is equal to A over hypotenuse is equal to B, and our sine x is equal to opposite side C over hypotenuse, which is equal to B, right? So we said that cotangent x is equal to cosine x over sine x. So when I divide like this, from here it's A over B times B over C. So these will cancel out each other, and from here we will get A over C. So as you can see, also this is equal to our cotangent x value. Now let's see how the cotangent function looks like on the graph on this unit circle. Okay, so this time we draw a parallel line to x-axis. Before, for tangent function, we draw a parallel line to y-axis, right? And this time we draw a parallel line to x-axis, and it touches the circle here. So since it touches to the circle, there should be a right triangle, right? So here how we do that, when you extend your radius like this to this line, okay, so from as you know from the parallel lines, the rule of parallel lines, if this angle is equal to x from this z, this angle is also equal to x, since these are parallel to each other. Okay, we can say that if this is equal to x, this is also equal to x. So from here we can from this point to this line to y-axis, this length is your cotangent value. Why? Because this is right triangle, right? Because it touches the circle. That's why this is 90 degrees. So how do we find the value of cotangent? Cotangent is equal to adjacent side over opposite side. So here our adjacent side is this length, and our opposite side is equal to 1, right? Here is 1, since this is equal to our radius. So this length is our cotangent x cotangent value. So let's find, for example, cotangent 0. Okay, so when you radius on 0 degree, which is here, right? So when it's here, since these lines are parallel and they will never intersect, we say that it is undefined. Okay, it is undefined. When I want to find the value of cotangent 90 degrees, so when you radius on 90 degrees, okay, like somewhere here, there is no horizontal line, right? So it's equal to 0. So when I want to find cotangent 180 degrees, it's same because our 180 degrees it's here. So when I want to find the value of cotangent 180 degrees, it is also undefined. Why? Because these lines are parallel to each other and there is no value. That's why we said that this is undefined. They will never intersect. That's why this is undefined. Okay, so when you want to find the value of cotangent 270 degrees, and it's here, okay, this is our 270 degrees, so it's same as 90 degrees. When you extend your radius to that line, since there is no horizontal line, it's equal to 0. So this is how you find the value of cotangent on this unit circle. Let's look at this identity of tangent and cotangent. So here we have tangent x times cotangent x is equal to 1. Why? Because we just learned that tangent x is equal to sine x over cosine x, right? And we know that cotangent x also equal to cosine x over sine x. So when you multiply these two together, let's do that. It's sine x over cosine x times cosine x over sine x. So these will cancel out each other and we will get the value of 1. Let's continue with cosecant and secant functions. So here when you draw a tangent line here, the length on the x-axis here is your secant x, okay, and here this y on the y-axis, this length is your cosecant x. Okay, so the formula for these identities, they are secant x is equal to 1 over cosine x and cosecant x is equal to 1 over sine x. So this graph actually will not be asked too much. Actually, it is not going to be asked, but you have to know these identities to solve questions about trigonometry.